going on, guys? My name is Will Dillingham. I'm one of the product managers with Inertial Labs, now a proud part of Viavi Solutions. Today we are here at Bear's Den, just outside of the Shenandoah National Park, and we're going to be demonstrating for you one of our latest features in PCMasterPro 1.13, and that is the ability to anchor a SLAM point cloud to a georeferenced coordinate system. Let's get started. So today I've got with me our Recipe ultralight system, and we're also working with our Recipe backpack. We've brought here a gnss antenna that we're going to be using to gather and record all of our raw gnss measurements. One important thing to remember during your collection process is that the accuracy of the total solution, being the point cloud that's generated from PCMasterPro, is dependent upon the accuracy of the gnss raw measurements that are gathered. Now that's anywhere from about 40 centimeters up to about a meter in actual usage. So what you're going to want to make sure that you do is at the beginning and as many times throughout the middle and at the very end, you're stepping into an area where you have good line of sight with satellites to make sure that your raw gnss measurements are as accurate as possible. Even though aerial LiDAR systems have come a long way over the last couple of years in the commercial space, it's still incredibly difficult to get good penetration underneath the canopy. That's why having a good SLAM solution and having the ability to anchor it to a global coordinate system is incredibly helpful. During the fall and winter months, trees shed their foliage. Capturing data both in leaf on and leaf off conditions are going to help users be able to estimate what kind of ground coverage might happen during those seasons. Other things like measuring simple volumetrics, measuring tree diameters, or understanding how many trees are in a particular area of the forest is also easily able to be extracted from the data sets. Before we start capturing, I'm going to make sure that my orientation is set up for SLAM. With ultralight, we want to see 90 degrees in pitch, so that's good. And then jump back. I see we got plenty of satellites, fantastic. And let's go ahead and name this project so I know which one to work with when we get back to the office. Appalachian Trail, Bear's Den. Perfect. And then let's go ahead and start logging and we'll start capturing. Let's go. Now let's go take a look at the data. All right, so we are back at headquarters. Different shirt, different day, but we are now ready to start processing. I went ahead and copied over all of my raw data onto my local computer. And in case you don't have a license activated, just go ahead and check the license menu. I see Kudan there. So that is good, and then we're going to make our way to the SLAM processing settings. We've got some defaults. If you're not familiar, outdoor is obviously where we spent most of our time. So I'm going to go ahead and select that one. And right down here, this georeference options. Currently, we just have one. This is the raw gnss with fixed trajectory. So what it's doing is a SLAM process, and then it's taking the SLAM computed trajectory and point cloud and dropping it into a georeferenced coordinate system. And after I have selected that, we're going to go ahead and exit out and then click, after I maximize this, we're going to go File, New, and we're going to make our way to our project location here and grab my raw data files and go ahead and open. And now PCMaster is going to start processing, and we are going to stand by while it does its thing. All right, so we are now looking at our final processed and georeferenced cloud. I'm going to color by laser so we can look at kind of the height profile, if you will. And this thing did really good. There's a small gazebo that we walked right past. And we will drop this down considerably. Fantastic. I mean, that looks very sharp. Okay, well, I'm satisfied with this. Let me go ahead and what I'm going to do at this point is go ahead and export this, and we're going to pull this into LiDAR 360 and do some further analysis on it. All right, so we got things pulled up now in LiDAR 360, and what you guys didn't see, I went ahead and took the liberty to do this off camera, but what I did is I pulled in the entire project into LiDAR 360, and I kind of only highlighted and zoned in on a smaller chunk of the entire data set. So as you can see, we got a bunch of different colors. I'm going to pull in and overlay what I calculated, which was dBH. And this is kind of a difficult view, so we're just going to go into glass. You can see my trajectory right there through the forest, and we're going to kind of tilt down, and you can see these are all diameters estimated by LiDAR 360 of every single tree that we scanned and walked past. When I ran the segmentation, I also generated a table that we can take a peek at here together that shows every single tree that showed up in this area and all the attributes that we discussed earlier in the video that would be helpful. That's basically dBH. You're going to see certain volumetrics and also positions and tree IDs. So that's how many trees we ended up with in this kind of smaller chunk of the data set. But this basically concludes the analysis part. I really wanted to show you guys what you can walk away with and how the data is useful. We're going to make this data available, so if you have any questions, feel free to reach out to us at Inertial Labs, and we'd be more than happy to either share the data with you or answer some questions. Take care.